Alright, so now we're going to talk about TRAM, or the trapezoidal rectangular approximation method. It's exactly what it sounds like. We're just going to use trapezoids, and we're going to try and fill in a curve to get an approximation of the area beneath the curve. So it looks a lot like this, and you could see this straight line here goes a little bit over this curve because it's concave up. If it was concave down, your trapezoid would go just a little bit under the curve. Alright, and trapezoid areas are calculated a little bit differently than rectangles. So let's go to the next page. We can see what. So here's the area formula for a trapezoid. It's a little bit different than a typical rectangle one. So the formula is going to be a little bit different. And remember, you could think like this is how you normally think of a trapezoid, with the base and the base on top, base on bottom, and then the height here. But for our purpose, we're going to rotate all these trapezoids so that the slanted part here is on the top, and our height is actually going to be left to right. And our height is actually the delta x now. And these are two bases. So a way of kind of thinking about this, if we were just doing one trapezoid, you would have your delta x divided by 2, and you would have your f of a plus f of b. But remember, we're not just doing one trapezoid, we're going to do several. And so we're going to see how this pattern fits when you're doing several trapezoids. In fact, let's kind of think about that before we go on to the next page, because I think it's going to help us understand how to set up these problems. So let's imagine, I'm going to zoom in here and just kind of imagine a situation where we have, let's say, 3 trapezoids. So we'll use our basic curve here that we've been using to talk about this. And let's say I'm just going to go to 3, and I'm going to do 3 trapezoids. Well, that means we should be able to clearly tell that our delta x here would be 1. But let's just think of it in terms of basic notation here. So our interval, like I said, is going to go from 0 to 3. And let's just think about what a TRAM of 3 would look like. Well, the first trapezoid would look like that, and then the second, and then the third. Okay, I know my drawings aren't perfect, but there's your 3 trapezoids. Well, instead of calling these 1, 2, and 3, let's kind of use some letters here just to kind of make some sense of this, because they'll be universal. So if our interval is from 0 to 3, then we could say, this is kind of like our A, and this is kind of like our B, right? So let's think about what each of these formulas would look like, right? Each of these trapezoids. Well, the first trapezoid, so we'll think, maybe we'll call this like T1, T2, T3. I just wanted you to see the pattern of how this is going to be calculated. So the first trapezoid, well, it's going to be just like our formula that we have right here below us, delta x over 2. And let's think about what our f of a and f of b would be. So it would be times f of a plus, we're going to add 1 delta x to a, right? One change of x. So this would be f of a plus delta x. And this would equal t1, right? All right, well, let's think about what t2 would look like. Well, it would have the same kind of, I guess you could call it a coefficient out here, or factor out in front. And now this first height here is the same as the last height before there. So that would be f of a plus 1 delta x. And now this second height, this is 2 delta x's away from a. So we could say plus f of a plus 2 delta x's. And maybe you're picking up what's going to happen here now. With the third one, we're going to see another overlap. And so we have delta x divided by 2 times, and again, look at this. This side shows up twice, just like this side showed up twice. F of a plus 2x, and then the final side is either going to be f of b, or you could say f of a plus 3 delta x. It'd be the same thing, but for simplicity, let's just call it f of b. Okay, and obviously our sum of these trapezoids is going to be adding all three of these things together. Well, this is what I want you to see here. Notice they all have the same number out front. So we actually could say for the TRAM 3 here, so for the sum of all these, we know that we're going to have, I might run out of space here, but we know we're going to have a delta x divided by 2 out in front. And if we were to just add all of these, we could add everything that's inside these parentheses because they already have the same kind of coefficient, if you will. And so you have one f of a, so let's just go ahead and put f of a. But for the next term, there's two of these. So that's 2 times f of a plus delta x. And there's two of these sides. So plus 2 of times f of a plus 2 delta x. There should have been a delta there. And then I'm running out of space, but the last one would be that there is just one f of b and so that equals TRAM 3. Now, what I'm wanting you to see here is, notice, the first and the last one, there's always just one of, because there's no overlap of that side. But all the sides in the middle are going to be multiplied by 2 if you were to think about it as a total sum. I mean, obviously you could do this, but if we're talking about, 10 trapezoids, then doing this each time is going to be a little bit redundant, but you could do, f of 0, 2 times f of 1, 2 times f of 2, 2 times f of 3, 2 times f of 4, all the way until you get to f of 10. And then the f of 10 would be by itself. So the heights on the end, the height here, if you will, and the height here, if you will, there's just going to be one of those. But all the heights in the middle are going to be counted twice because you count each height here when you do a trapezoid. I guess technically these are bases, but the way we're looking at them now, they become heights. So that's the pattern that's going to happen with trapezoidal sums. And so that's what makes this a little bit different. You're going to divide by 2 out here, and you're going to double all the heights that are in the middle. All right, now that we've gone over that, let's go to actually calculating out some of these problems. So same thing as usual. We're going to calculate our delta x real quick. We've done this several times now. So you're just going to do your b minus your a divided by your n. Again, there's your n. So this is 4 divided by 2, or 2. So your delta x for the first problem is 2. Then here we have 4 minus 0 over 4. That's 1. So your delta x for this one is 1. Okay. That part's pretty easy. Now let's get into the actual math here. All right, once again, let's make a little sketch just so we have something to look at. Going from 0 to 4. Call this 4, call this 0. There's just 2 trapezoids, so, and we already know from the above that our delta x is 2, so that means I can just go ahead and mark that as 2. All right, so what does our trapezoid look like? Well, it's going to look like the first one here and the second one there. And there's my 2 trapezoids that I'm going to find the area of. I get it. My drawing's not that great. Pretend like that's 1 point. Okay, so if we follow that from before, if we think about our heights, these are my outer limits here, right? So inside I'm going to have f of 0 and f of 4, but I'm going to count this height twice. So delta x divided by 2, because when it's a trapezoid we have to divide by 2. And we're going to have f of 0 plus 2 times f of, and this would be our a plus 1 delta x, which ends up being just 2. So 2 times f of 2. And then we're already at our outer boundary here, our outer limit here, and so we can just say plus 1 f of 4. So in this situation, there's only one height that shows up in the middle, so there's only one height that shows up that we multiply by 2. These are the outer ones, they're multiplied by 1. Well, let's go ahead and just plug all this in. We know that the delta x is 2, so we get 2 over 2 times f of 0, 0, plus 2 times f of 2. 2 squared is 4, so 2 times 4 plus the f of 4. F of 4 squared is 16, so f of 4 is 16. 2 over 2 is 1, so this is essentially just like saying 1 times 0 plus 8 plus 16, that's 24. And so now we've gotten a little bit closer. And we also can tell from our just simple sketch here that this is going to be a slight over approximation, right? Because these straight lines are going to be a little bit more. So 24, we've gotten a little bit closer to the approximation, and this is a little bit over. So we know the actual true area underneath this curve is a little bit less than 24. Okay, let's go to the next problem. Okay, similar idea here. Only now our delta x is 1. And so we're going all the way, we're going to 4, starting at 0. And so we're going to evaluate this thing at 1, 2, 3, and 4. So what would our trapezoids look like? All right, so we've drawn our trapezoid first from 0 to 1. It looks something like that. And then 0 to 2, 0 to 3, and then finally 0 to 4. All right, so we got 4 trapezoids here. And remember, our formula looks like delta x over 2 times. Remember, your first, I guess you could call it a base, but your first height and your last height are only going to be one of those. So this is just f of 0 plus. Now, all the ones in between, so the 1, the 2, and the 3, they're all going to be multiplied by 2 because they overlap. You're using them twice. So 2 times f of 1 plus 2 times f of 2 plus 2 times f of 3. And then finally we get to the last one. And so there's just one of those. That's 1 f of 4. Okay. So now we're ready to evaluate this. We know that our delta x is 1, so we can call that 1/2. And f of 0, easy. That's 0 plus 2 times f of 1. That's easy. That's 1. Plus 2 times f of 2. F of 2 is 2 squared is 4. Plus 2 times f of 3. 3 squared is 9. Plus just 1 f of 4, so 1/16. And so it may look like we're going to get a lot bigger area here, but remember, now we're multiplying it by 1/2. So we're actually going to get even closer. Remember, before with just 2 trapezoids, we got to 24. Well, now we should get a little bit closer. It'll still be a little bit above. It's still going to be an over approximation, but it should be pretty stinking close. So, what is this? We got 1/2, and we got 0 plus 2 plus 8 plus 18 plus 16. And from here, we're just going to add up these. So let's see, that's 10. That'd be 28. Another 10 would be 38, plus another 6 is 44. So we got 1/2 of 44, which is 22. So the cool thing here is, remember last time we had 24, now we got 22. So we got a little bit closer with 4 trapezoids rather than 2. And again, if we were to put in 8 trapezoids, we'd get even closer, and 10, and so on and so on and so on. So we're gonna keep working towards this idea of getting closer and closer and closer to the actual amount here. And maybe by now you've kind of figured out what we're working towards. But just keep thinking about that idea of the more rectangles or the more trapezoids you fit in there, the closer you get to the actual area underneath the curve. Okay. See you guys on the next video.